Let's start to apply everything that we've learned. In example 2, it says we are starting with an ellipse that has these vertices and these foci. Now, the first thing that I want to highlight is these are vertices, which means they've got to be on the major axis, because if they were on the minor axis, they would be called covertices. So I have my vertices and I have my foci listed right there. And this problem says to find the standard form of the equation of the ellipse. So I want to end with the equation of the ellipse that gives me these points. So I'm going to list my vertices. I have 0, 8 and 0, -8. And my foci 0, 5 and 0, -5. Now, to get a better picture of what this is looking like, I'm going to take a minute to draw it. So let's give ourselves some coordinate grid. My vertices, 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So there's my vertices. And my foci have got to lie on my major axis. They line up with my vertices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is what I know so far. So let's label a couple things we can get from this. First off, I know my major axis. I know my major axis and I know my center. The center's got to be halfway between these vertices and halfway between the foci. So my center needs to be at the origin. And from there, my major axis is going to be 8 long at this line, which is x equals 0. So the last things I need to figure out are my minor axis and my covertices, which might take a little bit of figuring. Now notice, the only thing that I haven't used so far is the equation for C. Let's look at that. So I know that C, my equation for C, is the square root of my major axis squared. I know my major axis, minus my minor axis squared. I do not know what my minor axis is. And I also know that C is going to end up being 5 long, because that's the distance to the foci. So once I have this all put together with this equation, I can actually solve for how long my minor axis is. So I'm going to square both sides, get rid of that square root. 5 squared is 25. 8 squared is 64 minus b squared. So let's minus 64 to both sides. And I get negative 39 equals negative b squared. Divide by negative 1, I get b squared equals 39. Square root that, and I get b equals the square root of 39. So there is my minor axis. So my minor axis is square root of 39. And it looks like this one has got to go side to side. So I'm going to approximate what square root of 39 is as a decimal, just so it's easier to count out on my graph. Square root of 39 is about 6.24. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 6.24 out, 6.24 out. There's my minor axis, square root of 39 in each direction. And it looks like it lies on this line, which is going to be y equals 0. And I can label my covertices as square root of 39, 0, and negative square root of 39, 0. And now that I have all that, I have everything I need to know to be able to graph what this ellipse looks like. However, remember, that's not actually what we're calculating in this problem. This problem didn't say graph. This problem said find an equation. So I need to take all this information that I've figured out everything that I've learned, everything that I've graphed, and now I'm going to come up with an equation for this graph. So there's my pretty graph. Move it over some more, give me some more space. Okay, so let's talk about what this equation looks like. Remember, it should be x something squared over whatever that axis is squared, the major or the minor, whichever one is paired with the x. And then I should have y, there's my k, and then this is the major or the minor, whichever one's paired with y, equals 1. So it's pretty easy to put my h and k in, 0 and 0. And then the axis that's paired in the x direction, that was side to side, that's my square root of 39, but I do need to square it. And the axis that's paired in my y direction, that's my 8 up and down, and I do need to square it. So here's my equation. Let's simplify it, make it look a little better. X plus 0 squared is just x squared. Square root of 39 squared is 39. Y plus 0 squared is y squared. 8 squared is 64. And all that equals 1. There's my final answer. That's the equation for this specific ellipse. So now I'm going to have you try one of these application problems. In example 3, you are given 2 of the foci and 1 of the vertices. You need to graph all of this, use that graph to come up with the rest of your information, and then use that information to come up with your equation. So pause the video, read through this one, and try it out on your own. Let's check your work. So first off, these are the ones I started with. I knew these foci points, so I knew both these yellow points, and I knew this vertex. So it tells me that vertex, so I know where the major axis is. I know that this is going to be the major axis because it has the vertex on it. Now, the first thing I found was my center, because it has to be perfectly in the middle of my foci. So if these are my 2 foci, that's got to be my center at 3, 1. Now, if that's my center, that means my major axis is 3 long at y equals 1, this line. So using that, I found my other vertice, which was at 6, 1. Now, next thing I needed to find was my minor axis. So I used my C equation for that because I know that C is 1 long. That's the distance from the center to the focus. So that's 1. And then I took my major axis squared minus my minor axis squared, which I didn't know. Solved for my minor axis, and I got square root of 8. So I know my minor axis is square root of 8. It's got to be up and down. So I went square root of 8 up, square root of 8 down. And that's how I got my covertices. Now, notice that I kept my answer exact. I did not turn it into a decimal. That this point is this point, 1, plus square root of 8, and this point minus square root of 8. So I kept those exact, no decimals. Then I used all that information to plug it into my equation and come up with my final answer. So hopefully you feel pretty good about applications of ellipses. In the next problem, we're going to look at completing the square for ellipses.